Exciting. Great. All right. Hello, everybody. Happy to be here. My name is Elliott. I've been working with AI since I was a kid, really. I launched my first AI model in the late 1990s, Webby nominated for my work on the Wall Street Journal World Stream, which was at a Stanford Research Institute AI spinoff. And basically, we did natural language understanding, transcription, and stuff like that. Think TikTok before TikTok. So the AI would automatically transcribe videos and figure out what the video was about and do things like auto moderation and stuff like that to help live broadcasters integrate viewer videos into their live broadcasts, so they could tell viewers, hey, send us a clip of whatever, and then or tell us what you think about this topic, and the viewers could record video and send it in while the program was airing. And while they're on the air, they could very quickly sort through all those videos and find stuff. Yeah, so anyway, I've been into AI for a long time, since way before ChatGPT came out. And I've been doing AI-driven development since 2020. And I created my own programming language for that purpose that runs on top of large language models, which you're about to see in a second. But today we're going to talk about some things that will take you a little bit beyond vibe coding and into AI-driven development, like true AI-driven engineering, right? So one of the tools that we use in software engineering is called a design system. And the purpose of the design system is to help you as you're building a bigger, more complex app. It's to help you keep your user interface consistent across all of your different views by using the same styles for, buttons and inputs and cards and layout and stuff like that, meaning the same kinds of spacing, the same kind of everything. So your design looks consistent, like it was designed by one person instead of 30 people and in different moods and stuff like that. You may notice that when you're vibe coding, the styles can like radically shift from one prompt to the next, and things can get a little crazy. But with a design system, you can use that to help keep the AI on track in terms of the visual look and feel and overall, style of your application. And one of the cool things about AI is you can actually vibe code a design system. And that's what I did. I vibe coded my design system, and I just made an HTML prototype of it. And then I had an AI agent convert that into actual components. And I use this program called Storybook that lets you look at all the different components and learn how to use them in the app and so on. But the interesting thing about Storybook is that you could just tell the AI about your storybook, and then it will use those components to build out your user interface. So right now, what you're looking at is on the left side of the screen, you see the Storybook, and it's showing us basically an overview of all the different buttons we can use. And oh, by the way, this little hover shimmer effect as we mouse over it, Claude did that kind of on its own, but I really love it. I love that mouse over effect. That's pretty cool. So I was telling it to use like a glass cyber morphism kind of thing, or a cyber glass morphism kind of thing. So it's kind of got this, this shimmery kind of look to it, which is pretty fun. I like it a lot. But you can see it created like a bunch of different variations of the buttons and things like that. And this design system includes like examples of like how to use the thing in the application. And I love this. It's disabled button. I actually asked for this one, right? But the disabled buttons turn red and shake when you mouse over them. And the loading state is saying, hey, we're loading something, we got to wait. So it's like if you press generate for AI or something like that to try to get something out of, like, imagine you're trying to generate video, right, with a AI generation app. When you click on the button, you're not going to get a video instantly out to give you feedback. So instead, you can disable the generate button and replace it with this like little loading button, a little loading state button, so that it doesn't let the user keep on clicking, right? And trying to launch more generations while they're waiting for the one that's in the queue. So yeah, but I asked it to do this cool little shake on the errors and stuff. So it does that. It's pretty fun. And then we have our, icon button. So you can set an icon for to the right or to the left. In this case, to the right, the little checkbox is our icon in this case. Yeah. And then we can have buttons that are just icons, like a little settings button for a settings panel, or X to close things, or, things like that. I probably wouldn't make those primary buttons in an actual application, but yeah, pretty cool. So yeah, we've got buttons. We've also got some input fields and stuff like that down here. So hello, right? And it represents all the different states and things like that. These are the kinds of details that an AI can overlook when you're vibe coding, but when you just kind of prepare a whole bunch of components for it in advance, and then it can just use the components that you've already made, it's never going to forget to like add the little border when the field is active, or do a little error border when the input is invalid. All right. And did you notice that little shake when we entered into the error state? And if we go from the valid input form field to the error input form field, you see it like shakes right when it loads. Yeah, so that's really good real-time feedback as the user is entering some invalid input, right? Getting that real-time feedback of that like shake is pretty cool. Yeah, so this isn't perfect yet, but the design system itself, the prototype for the design system, I vibe coded that in like 10 minutes. I just kind of gave it a description of the style I was after, and I said, let's create a design system, and I listed some of the things that I wanted in a design system, and I'll share these prompts later. I have an open source repository where I'm sharing all these various prompts for AI-driven development, and so I will share that with you later. But for now, what you got to know is you can do all this stuff so the AI knows how to create your application. And then over here on the right side, what we've got here, and here, let me just expand this. So what we've got here is our style guide for writing JavaScript. So one of the serious problems with vibe coding is that the resulting code is very rarely maintainable in any real sense of the word, right? And what I mean by that is like it doesn't use good standard coding conventions all the time. And here, let me close this little storybook terminal. So it doesn't know to use like good coding conventions and stuff like that. Basically, by default, it acts like a very average programmer. But when you tell it to act like a top-tier software engineer and then give it some specific guidelines that maybe a top-tier software engineer would actually follow, then it writes much, much better code. So you can see we have act as a top-tier software engineer with serious JavaScript, TypeScript discipline to carefully implement high-quality software. So we're not just saying, make me an app, right? We're saying, make me an app, but also make sure that you use really good code to make the app. We care about code quality, right? And that kind of creates the distinction between, are we just vibe coding a quick prototype, or are we building something for production? And in my case, I already had a prototype, and now I'm turning that prototype into a production application. So I want serious high quality code that is maintainable, so that as I continue to work on the application and I continue to build on the application, it's going to be easy to add to without breaking things. And that's kind of a key distinction between a vibe coded project and like a real product that you can ship to end users and make money with, right? It's like, how well can we maintain this thing? Can we fix bugs and add new features without breaking other things? And in order to do that, you have to make sure that the code quality is good, right? So that's what this is about. So here we say, before writing code, read the lint and formatting rules so that it knows how to style the code. Observe the project's relevant existing code, which means like, don't just use whatever random convention you want during this prompt execution. Actually pay attention to the surrounding context, to the rest of the application, and make sure that that what you're doing is cohesive with that. And that makes the application easier to maintain and extend and debug and stuff like that, right? So conform to existing code style, patterns, and conventions unless directed otherwise. Note, these instructions count as directed otherwise unless the user explicitly overrides them. So meaning, if you see bad patterns in the existing code, right, these directions override those bad patterns. But if the user explicitly says, hey, ignore this directive for this particular piece of code and just do what I tell you, then the user can still intervene and say, no, do it this way. All right. So down here we have constraints. So what you're looking at is a programming language called pseudolang. And this little MDC up here, this is cursor rules file format. And MDC is just a markdown document with some metadata at the top, which helps the AI understand what it's looking at and when to use this thing. So in this case, anytime it's looking at JavaScript files or JSX files or TypeScript files or TSX files, right? Anytime any of these file types are active, it's going to try to load this whole thing, this little program, into its context window so that it understands how to write the code for those formats. Anyway, so pseudolang supports Markdown. So you can just create like this natural language Markdown guide and then give it some instructions and give it some constraints. And so constraints is from a programming paradigm called constraint-based programming that was invented by Ivan Sutherland in the 1960s. And he made this really cool really cool thing called Sketchpad, which was like a visual programming language. And you could like draw a bunch of lines and then highlight them all and throw a little switch. And the little switch means make sure that all of these lines are mutually perpendicular. And then from then on, when you move one of those lines or resize one of them or rotate one of them, the rest of the lines kind of solve for that mutually perpendicular constraint at runtime. And constraints in pseudolang act the same way. So they can dynamically update state based on changes to other parts of the state, which is pretty cool. So constraint-based programming. And like I said, this programming language runs on top of a large language model. This programming language was not possible before AI became a thing, but now it is possible. And you can code entire applications in pseudolang and transpile to any other language. And in this case, we're just using, this is a kind of metaprogram. And a metaprogram is just a program that teaches the computer how to write programs. So in this case, we're teaching the AI how to write good JavaScript, right? Like I said, this is called metaprogramming. Programs that write programs. It's called metaprogramming, right? So now we have our constraints. And these constraints are things that like senior level software engineers would think about that maybe beginner developers might not think about, and maybe the average code implementations on like Stack Overflow and GitHub probably don't follow all of these processes well. And the problem is that AI tends to lean on stuff that is seen a lot. So, and it's seen a lot of really average code because it basically looks at like all the code out there. And when you do that, it creates like this average sum of like the code quality of all the code out there. So by default, language models are not very good programmers, right? But if you give them some instructions and you give them a little context and say, hey, I know you know how to do this, right? So don't be lazy and lean on just like what you would normally just default to. Actually think about writing high quality code. And when you do that, then it writes much better code. So anyway, it says favor functional programming. So the reason that I've got this here is because functional programming tends to create way more concise code, which is like way less code. Hello, Sleepless Robot from Germany. Nice of you to join the live stream. All right. So yeah, like I was saying, functional programming tends to create much more concise code, which means there's less code to maintain and less code. You want to keep your code uncluttered for the same reason you want to keep your house kind of uncluttered, because like more clutter equals more surface area for bugs equals more bugs. So if you can express the same idea with less code, you should definitely do that, because you'll end up with fewer bugs and less to maintain. And every bit of code that you write is a maintenance burden. It's something that you have to worry about breaking later on. So if you can write the same thing with a lot less code, you should do that. And functional programming takes a lot less code than imperative styles. Or an imperative style is kind of like step-by-step instructions, exactly how to do this thing, right? So in imperative style, you might write a for loop. In a declarative style, you might just say, hey, I want to apply this transformation to everything in this set, instead of explicitly maintaining a counter and saying like, okay, first initialize a counter to 0, and then after the first pass, add 1 to it, and then after the second pass, add another 1 to it, and so on. And then it counts like, where am I in the position of this like collection? You don't have to do all that, right? So here, let me adjust my mic so I'm not blasting everybody. So you don't have to do all that. You can just, yeah. Yeah, you can use declarative approaches like map and filter and reduce and things like that are functional programming tools that basically just say, hey, apply this logic to this entire collection, and we don't care how you do that. We don't like actually manually iterate over everything and add ones and stuff like that. So yeah, it's less code. So this one is just saying one job per function, separate mapping from IO. In this case, we're just saying, hey, don't write a function that does all the things, right? Write a whole bunch of smaller functions and then piece them together like Lego building blocks. So this is telling it favor composition over like cramming everything together in one giant function. And there's lots of reasons for that. But one of the chief reasons for it with AI-driven development is that AI language models have limited number of attention heads. And just like humans, we can't keep everything in our working memory all at once, which is why we kind of put dashes in phone numbers and stuff like that so we can chunk things. We actually have a limited number of slots in our working memory. And when we try to remember too much new information all at once, we forget little bits of it, right? So humans can memorize or can keep in their working memory an average of like 4 to 7 things, right? Which is like 4 to 7 chunks of memory. Language models have a limited number of attention heads. And when I say a limited number, I mean a few dozen attention heads. And the reason for that is because as you scale up the number of attention heads, attention scales quadratically, which means that as you add more tokens to the input context, right, the cost of calculating all of the attention weights between one token and another token scales exponentially, quadratically in this case, right? So in other words, the computational cost is the square of the number of tokens in the context window. So the problem is that attention heads have a limited number, language models have a limited number of attention heads. So you got to really kind of conserve the attention. Even models that can handle like 1 million tokens of input, it still doesn't use like 1 million attention heads, right? It uses a few dozen attention heads to handle 1 million input tokens. And the problem with that is that you're going to lose some of that context. It's not going to be able to pay attention to everything in the context, just like a human can't process an entire book all at once, but we can, scan through it and find stuff in it. Language model attention heads can do the same thing. They can, when you ask it to search for something in the context, they can some of the attention heads specialize in searching the context window. So they can kind of do that a little bit. Breaking things into smaller functions helps a lot. And as a general rule of thumb, you want to keep like each file or each module under 160 or so lines of code in order to maximize or to keep within that optional attention span of the language model. Even for the best models in the world, once you go beyond 160 lines of code or so, it starts to degrade in how well it can pay attention to everything in that code all at once. And the problem with software engineering is, especially with like really tightly coupled stuff that tries to cram everything into one big function, the problem is that you lose a lot of that. You dilute that attention capacity. So it starts to forget things and you're more likely to introduce bugs. So keep your files fairly small, like within like 160 lines of code. So this is telling it more of that same thing, omit needless code and variables, prefer composition with partial application and point-free style. This is basically just saying, hey, if you can just take the output of one function and pipe it into the input of the next function without creating a variable to hold on to that data in between those two functions, instead of explicitly passing the output from one function to the other through an intermediary variable, why don't we just like clob these functions together, right, one after the other like a pipeline, and do that with function composition in point-free style. Point-free just refers to the fact that we don't need a variable to hold on to the output from one function to pass it to the other function. Instead, we're just going to put those functions together like a little pipeline. We're just going to screw them together like a pipe, right? And then they'll act like one function instead of two, and then you won't need any intermediate variables. You can just pass the output from one into the input of the next, and you're good to go. All right, so this is saying keep related code together. It's just talking about keep your code organized, put statements and expression in positive form. This just makes it a lot easier to understand and a lot more concise, right? Use parallel code for parallel concepts, enables transfer learning so that if the AI knows how it did one thing and then there's another kind of similar thing, it can just apply what it learned about doing one thing to the thing that it's doing now, and utilize transfer learning so it doesn't have to like use its attention capacity for keeping track of how all the different code works, right? Here we're saying avoid null and undefined in arguments, instead use options, objects. And this is just saying, like, when you call a function, normally you would do like foo, bar, baz right here, right? But if baz is, if you don't need baz, but you do need something like biff, right? If you don't need this guy, but you do need this guy, is maybe there's a sensible default for this guy inside the foo function. Normally you would have to pass undefined here, right? You don't have to do that if you put these in like named parameters like this, right? So here we do the named parameter syntax, and then we can just omit this because it knows which ones we want, right? The problem with omitting these little braces is that now we have to obey argument order. So if it's expecting foo, then bar, then baz, then you have to pass something for bar even if you don't have something to pass for bar, which forces you to type out like undefined instead of just doing the named parameter thing. Takes away the need to have it ordered, because it's going to have a parameter name. It's going to say, oh, this is foo, right? So we can just pass foo like this. This is equivalent to doing like this, right? In JavaScript, we have this shortcut where we don't have to actually type it like this. If you have a variable named foo, then you can just pass it like this. And if you have a variable named bar, you can just pass it like this. right? And if you have a variable named Baz, you can just pass it like this. So if your variables are named after the expected function parameters, then you can just pass them explicitly like this. But now we don't have to worry about argument order. So instead of passing undefined for bar, we can just omit it entirely and save some code, save some tokens, right? So these are like tools that senior developers have used just to keep their code uncluttered, but works really well for AI because now the AI doesn't have to worry about cluttering its context with that. Here we're saying chain operations rather than introducing intermediate variables, which is kind of like the pipe operation that I told you before. But in JavaScript, we have this function chaining capability where if one function returns an object and that object has a method on it, we can just use dot and then the method name and invoke the next function. And in doing so, now we don't have to define an intermediate variable to pass the data from one function to the next. So it's basically the same thing as the piping operation stuff, the point free style stuff on this line, on line 23 up here, but it's saying a different way. So maybe actually I should organize those together. Like maybe I should move that up to the partial application and point free style thing like that. There we go. And here we're saying use concise syntax, arrow functions, object destructuring, array destructuring, and template literals. So in other words, instead of doing const a equals object.a, we do const and use the little curly braces, which represent destructuring in JavaScript, destructuring assignment, and then just tell it, we're going to pull the property a from this object. And that saves us some tokens. It saves us, and saving tokens, like I said, is really good because it helps the AI behave better. It'll hallucinate less, make fewer mistakes because we've got less token clutter in its context window. And here we have assign reasonable defaults directly in function signatures. And this is the trick that allows us to omit, like I was saying with the foo bar baz example here, with the named function parameters, right? This is the syntax that allows you to do that, right? So assign reasonable defaults means like if we're expecting an ID and the user isn't creating the ID, right? We're generating the ID. Maybe we can just create a default value for that ID right in the function signature. And then when the user calls, create expected user, right? Like create expected user. Now they don't have to pass the ID because it has a default value. Now they can just pass name. In my case, my name is Eric, right? Description. Eric is a software engineer. Good. Yeah, Eric is a software engineer, right? So that works out really well. In JavaScript, when you have default parameters assigned to like an options object like this, you'd still have to create a default for the object itself. So if they don't pass anything at all, right, it'll default to this empty object, and then it'll try to destructure from the empty object and assign default values to anything that's missing from that object. So in this case, everything is missing from the object, so it'll use the defaults for everything, right? And then here we have the principle, function callers should be able to understand the expected call signature by reading the function signature. This means that parameter values should be explicitly named and expressed in the function signatures. So instead of just saying payload equals some empty object, right? We really want to define what properties should exist on that payload, like ID, name, description. And in that way, when the AI is trying to figure out how to call the function, it can just look at the function signature and find out that information very easily without wasting computation resources, like reading the entire function to try to figure out what it's expecting, right? So just make sure that you're making that explicit in your function arguments, and you're in a good place. Or function parameters, your formal parameters. These are the defined parameters of the function, right? And notice how default values also provide hints for type inference. So in other words, if I've got a function, here, let me just create a new, let's save this as foo.js. So if I've got a function const foo equals options, right? And then I just console.log options.bar, right? And then I try to call this function foo. Actually, in our case, it actually does have a pretty good understanding because we're using cursor, and cursor has AI autocomplete. But back before AI autocomplete, you would need to rely on the language services, and the language services would need to do type inference, and it's usually not very good at inferring types, especially if we just did options like this. Now we have no type hints. So if I did foo, like it doesn't know like what options should be there. So maybe we have options.user, right? And we want to log that, but we don't know that options.user exists. Now it's saying foo baz, right? But there's no foo or baz or anything like that in there. So the AI is just guessing, and it's guessing wrong, right? But if we did this instead, if we replace this with like user, right? And create user, something like that. And then up here we have create user. And then I'll just like, actually, I'll just do here. Yeah. Something like that, right? So now the AI is going to be able to give us better hints. See, so now it knows that its name and ID, right? Because we spelled out the explicit requirements, right? Like we told it, hey, this is going to be a user object because we're calling create user, and it can see what properties create user has. So now it can just infer all that stuff. But if we had left off the function arguments entirely, right? If we just said options, then it wouldn't have known to do that stuff. So yeah, here, let me get rid of this. Don't save. In fact, I'm gonna like here, new terminal. Did I create it in this directory? Oh no, I didn't. I'll have to find it later. I'll get rid of it later. Okay. So where were we? Explicit argument names. Yeah, explicit parameter names. Here we're saying avoid using this old syntax for defaults. JavaScript used to have a much more clunky default value syntax that was also very error prone because it wouldn't assign falsy values like 0, but maybe 0 is the right value and it should have assigned it. So use default arguments instead, and it'll work a lot better, right? And here we're saying prefer immutability, use const spread and rest. So immutability is an interesting topic. In functional programming, we favor immutability because we don't want to ignore history, right? For the same reason that you don't want to ignore the history of your bank account, right? You want to see exactly which transactions happened to update your bank account balance, right? So you're not confused about where did my money go, right? You can look back at the transaction log and see exactly where your money went, and you can rebalance it on your own, checkbook accounting ledger and stuff like that. And you can keep track of your money better, right? So the same thing happens with application state, right? When we just mutate application state willy-nilly, like any way we want, the problem with that is we lose our complete transaction history. We don't have a good understanding of how the program state got into the state it's in, and that makes debugging a lot harder. So what we want to do is we want to favor immutability instead. So we're going to use state management libraries like Redux, and Redux uses pure functions. And pure function is a function that, given the same arguments, always returns the same output. So it's deterministic. So you can do the same thing over and over again, and you're always going to get a reliable value out. But it also it doesn't mutate anything. So if you pass in some arguments, it's not going to make any changes that are going to affect other things that depend on those arguments. And if you use a central dispatch system like Redux has store.dispatch, right? And when you do that, it actually sends a transaction to the state management layer of your application, kind of like initiating a transaction with a bank account. Now you have a record of what it was that changed your state. So you know, like if something goes wrong, you know where to look in the code for the problem. So immutability is really good for those kinds of things, but it's also good for performance in some ways because when you use immutable objects, you can just look at, is this object the same as this starting object? And if it is the same, then the starting object did not change, which means that we don't need to do things like update the UI, right? And we can just skip the whole process of doing a UI draw if nothing changed. And that can help with performance, right? And likewise, with mutation, you would have the problem of now you might have to go deep dive into that object to check to see if anything changed. So if you use mutation-based API, you might have to crawl through the entire after object, right, and compare it to the entire before object, one property at a time, deeply nested, right, which means like layers of recursive looping to try to find and make sure that nothing changed. You have to walk the entire tree, visit every node in the state tree, and compare everything one at a time to see if something changed, and we need to redraw our UI, right? So we want to prefer immutability instead of doing that. There's another pattern, which is basically what React is all about, right? React is called React because it's named after reactive programming, which basically just lets you observe the state, and when it changes, we update the UI. Right? But in React, you would normally have to do that comparison to see if anything changed. But you can actually make all of the properties of your state tree observable, which means that then they will notify observers whenever they change. So you can just subscribe to a specific part of your state, and you only redraw the stuff that depends on that part of the state when that specific part of the state changes. And so a full reactive thing would be much, much more performant, which is really cool. And we'll get to that later. Yeah, we'll get to reactivity and stuff like that later. Actually, I've got probably some other lessons and stuff on that topic somewhere else. But anyway, so here we're just saying prefer, map, filter, reduce over manual loops. I could probably move this up to functional programming, favor functional programming. Yeah. So over here, I think we could do that. I should group these related topics together better like this. And then prefer immutability. That's also more of like a functional programming kind of topic up there. So I'm just going to move that up here too. Sorry about that. I'm like updating updating the program as I'm showing you the program just to kind of, you know, keep it more logically organized. All right. So prefer async await over or async pipe over raw promise chains. So a promise chain normally looks like something like promise dot then foo dot then bar dot then baz, right? But if we use async pipe, that could look like that could just look like const do thing equals async pipe, and then you just do foo bar baz, call it a day, right? So you can see here, like to really get the equivalent, right? This is the equivalent. So this is larger code, right? Here. Right here, we'll do fetch dot then. That makes more sense. Fetch thing dot then foo bar baz, right? And or we could do, so here we're calling foo bar baz, right? And then we can just do fetch thing. So this, I'm just trying to make kind of equivalent code here, and this is kind of like a contrived example, but I just wanted to show you the difference in See, it's a little more concise using async pipe, right? But it's also a little bit more readable because very often you might have some like inline stuff. Very often when we're using promises, we tend to like write other like mini functions inline to handle the output. In this case, we can do a lot better by like naming those functions explicitly and then just running them through async pipe to make this declarative thing. And one thing that I like to do, I like to use this in server-side routes and stuff like that. So it's pretty cool. I'm not going to go into all that detail now. We can talk about that later, but that's what that rule is about. And here we're saying use strict equality. JavaScript has an equality operator that looks like this with like 2 equal signs. You don't want to use that because this does type coercion automatically to compare values like strings and numbers. And if the string contains the same number as the number, then it's going to return true when it's the wrong type. So it probably should return false. So strict equality checks make you explicitly cast to the type that you want to compare, which can reduce the number of errors. So this is kind of just like a avoid an entire class of bugs kind of rule, right? Here we have modularized by feature, one concern per file or function, prefer named exports. This is basically just saying keep your code modular, use building blocks and put them together like Legos to compose whole applications. And that just makes the whole thing easier to maintain. So if you have something in one part of your app, it's not going to break something in a completely different part of your app, right? And here we're saying avoid class and extends as much as possible. And this is another way of just saying like write more modular code. And we're going to use, we're going to prefer composing other things. In fact, I'm going to say prefer composition of functions and data structures over inheritance, right? So in other words, we're saying program using functions instead of like composing a bunch of stuff into a gigantic God object that just globs everything together, right? And that avoids like some common problems in software engineering. Here we're saying avoid loose procedural sequences, compose clear pipelines instead. I could probably move this up to the bits about using function composition a lot better. And maybe also this, I can like move that up with this function composition stuff instead. There we go. Group all that kind of together a little bit more. All right. And then we have naming conventions and just tells it how to create good names for things. In software engineering, like there's a joke about about hard problems, right? There's 2 hard problems in computer science, right? Naming things and I forgot the other one. Off by 1 errors, naming things, and cache invalidation, right? 2 hard problems. Naming things is hard, but these are just like some tips to help the AI create better names that are more readable and more understandable. And that helps both the AI and the humans understand what's going on in the code. So now you can see we're going from vibe coding to creating like really good, well-written code. And you can see the result of this. Over here, I'm working on building a new app. And this new app is actually an app that helps people turn their vibe code kinds of ideas into well-written software applications. And so, yeah, it's basically just like giving you access to all the agents and rules and stuff like that I've created here. Here, I'm going to get rid of this thing because now I can see where that file is made. All right. So let me just show you. If we go, I'm in the cursor rules. What? Okay, yeah, got to go into the app folder. All right, so if we go to our source folder, and then we go to features and user authentication, I kind of use the agent to go through and use something called test-driven development to create a bunch of files here. So we can go and look at user auth tools. So that's just checking to see if password is supported. Okay, so those are the requirements that I use. So another thing, like just kind of like using the design system that I showed you earlier. Here, in case you forgot, I'm gonna just exit full screen and then pull up the design system again and kind of show you what that looks like. So where's the overview? There's the button showcase. So the design system just gives the AI a bunch of pre-built components that it can just use so that it doesn't have to like reinvent everything from scratch every time you tell it, hey, make this feature or make that feature. It just has like these pre-built components that it can just plug in and start using. Same kind of thing is happening here. With we got our UI components, features. Okay, so with the requirements kind of act like a design system, except it's not for the UI, it's not for the look and feel, it's for like, these are the things that the software should do. And this is kind of a more organized way of prompting the AI to tell it what to build. And in this case, we're getting into really specific detail about how it should handle our authentication flow. So those are the requirements. And now if we look at the actual implementation code, this is the code that the AI wrote. And you can see it's using some default assignments, and you can see it's applying the rules that I told it to apply in that JavaScript style guide. So the AI wrote 100% of this code. I did not write a single line of this code. This is all written by the AI, but you can see it's reusing the slice here. So it's creating variables, reusing those variables, and it's doing everything by the book. It's doing a really good job. This is code that I would expect to see out of a senior level JavaScript engineer. It's really well organized, really well broken down. There's isolation between the state and it's using this immutability concept, right? So instead of changing the existing object, it's returning a new object. So it's obeying the pure function rules. And when you're building Redux code, you really need to obey the pure function rules or things might break. And what I mean by that is the user might change something and then their change won't be reflected in the user interface and they'll be really frustrated with that, right? So yeah. So anyway, that's the result. So to recap, if we give the AI some really clear instructions on how to write good code, it will write good code like a senior JavaScript engineer would write, right? So this is really good code. And you may not see like the TypeScript nerds in here might be thinking, oh, but there's no types. Yes, there are. You just don't have to explicitly specify them because it can infer the types from the function signatures, right? So when I run TypeScript against this file, it will type check it correctly, even though there aren't any explicit TypeScript types in this file. And I do that all the time. So, and that is a tool that I will, this project, I just started this project this week, so I haven't got into that on this particular project yet. But yeah, I will enable type checking and so on and so forth. So anyway, that's the basic overview of how to keep your AI on track. So number one, make a design system. Grab Storybook, install Storybook. You can actually have the AI install Storybook for you, which is what I did here. I had the AI install Storybook. It made some mistakes, like it used the wrong module setup. It tried to use module.exports, and my project is using native JavaScript modules because it's 2025. We don't do module.exports anymore. We do export, right? Just regular JavaScript modules, right? So it tried to use the wrong module output type, but I corrected it, and when I corrected it, it got it running. So it installed Storybook and it did all this stuff for me. I still had to know a few things about JavaScript and stuff to get it to work really well. So that's the problem with vibe coding. It's like, you're going to have to learn some stuff to go from vibe coding to producing production ready applications that your users can actually use. So But this is a good start though, because this will help you. Like I actually have already open sourced a lot of these rules and stuff. So this file for JavaScript rules is in an open source repo that I'm going to share later. If you're not following me on Threads, that's where I post most of my content on AI-driven development. So you should probably go and follow me there, right? Go and follow me there, and I'll post links to all these things, and hopefully I'll find some time to go back to all these like live streamed things and add links and stuff like that to the files and stuff. Anyway, that's basically the recap. If you want, I can give you one-on-one mentorship to teach you how to do all this stuff and teach you how to use these things and teach you how to turn your vibe coded stuff into real production applications. Or if you're an experienced software engineer already and you already know all this stuff, but you're not sure how to use the AI, I can show you how to do things like this. This file just tells the AI how to do test-driven development. So basically, we're giving the AI the same tools that a software engineer would use, the same processes that an experienced software engineer would use. And maybe if down here, you can see the process. For each unit of code, create a test suite, one requirement at a time. If the user's not specified a test framework or technology stack, ask them before implementing. If the calling API is unspecified, propose a calling API that serves the functional requirements and creates an optional developer experience. Write a test, run the test runner, and watch the test fail. So when we get the AI actually doing this stuff, you can see it writes a test, then it runs the tests and watches it fail, right? And it's important to watch it fail to test the test, right? And then it implements the code and then watches the test pass, right? Implement only the code needed to make the test pass, run the test runner, see it fail. If you see it fail, fix the bug. So this is actually a JavaScript conditional, or sorry, not a pseudolang conditional here. This is called pattern matching. So it says, if we see the test runner fail, fix the bug. If we see it pass, continue, right? That's what that means. Fail, fix bug, pass, continue. So that's pseudolang right there. Get approval from other users from the user before moving on. So it's saying, like, wait, don't just move on to the next requirement yet. Let the user verify that this requirement was correctly implemented before you move on, and then repeat the TDD iteration process for the next requirement. So that takes the requirements that you just saw. Here, let me show you again real quick. Requirements. So that converts these requirements one at a time into unit tests. And then the AI implements the software and runs the unit tests. And what this does is it builds up this, where did the TDD one go again? There we go. So what this does is it builds up this test suite so that as the AI is building new features, it does not break existing features. Because if it breaks something, it's going to see the test fail and it's going to realize, oops, I broke something. And it's going to go and fix that and try again. And in this way, you can keep on adding new features without the AI breaking all the existing stuff that you already had. And this is a big problem in vibe coding. This is why it's really hard to vibe code more than basically a one-off prototype, because as you're vibe coding, you create a new feature and you end up breaking other features. And this was a problem in human development as well. This is not a unique problem to AI. Humans had the same problem before we started implementing processes like test-driven development. We would write a feature, we would forget about testing all the other features, and we maybe broke another functional requirement in the process of writing our features. And a big problem with software is like often our functional requirements are not even well documented anywhere. But following this process, we document our functional requirements very clearly, right? So using this like given should syntax, and the AI, by the way, knows how to write these requirements because this meta program exists that tells it how to do that. So down here we have our requirements again. Here that's user auth dex requirements. Yeah. So as we add new features, first we start with the requirements. right? And then we start to implement and add the feature using tests. And as we do that, we make sure we're not breaking anything. So yeah. Any questions? Yeah. So anyway, this is already open source. This javascript.mdc file is also already open source, and I will try to post links to those locations and so on. Yeah, I don't know who's here. Here, let's see. Yeah. Anyway, I don't see any questions, so I'm going to wrap up the stream. Thanks for checking it out, everybody. Yeah. For experienced software engineers, this is how you get AI to write software like an experienced senior human engineer would write software. And for the newbie vibe coders, you got a lot to learn. But these things, these little meta programs will help you learn it, because these rules are there for a reason. And one thing that you can do if you're just starting out is you can go into your agent. You can open up your agent chat here. I'm going to open our agent chat window and close that little file sidebar so you can see things. And we can say, we can take like one of these requirements and we can say like, we'll just paste this in here and say, why is this important? And then it'll explain to you why it's important, right? In some pretty good detail. So in other words, as you're coding, right, as you're building your application, you can learn how to build the application from the AI, and the AI will show you. This is the thing that I was showing you before. Let AI blah, right? This is manually iterating and keeping track of the counter and stuff like that. Versus this version, right? It's just way more concise, fewer tokens. The AI is going to make fewer mistakes. There's less code to maintain, less surface area for bugs to hide in, and so on, right? So as you read these things, you can just paste it like one thing at a time, and you can say, why is this one important, right? You can say, what about this constraint? Why prefer immutability, right? And then it'll explain that one to you, right? So the AI knows this stuff already, but you still have to explicitly tell it, hey, do these things. Pay attention to this stuff as you're writing code. Because like I say, AI is pretty lazy and it'll default to like patterns that it's seen over and over and over again by default. So this stuff will teach the AI how to do things better, but it can also teach you about all these concepts, because you can just ask it, hey, why? Why should I do this? Why is this important? And it'll tell you. All right. I think I've been streaming long enough now, and I got other things to do. I got to like actually make progress on this app. So I will talk to you guys later. Goodbye. Actually, maybe I'll just leave the stream. No, I'll start a new stream. All right. I'll talk to you later. I'm going to start another live stream right now, and you can actually watch me use this to build the application. I'm going to do a lot less talking and more kind of working, because I really do need to like make some progress on this app. But you can hang around and see how I do things. So go to my channel right now. Hit subscribe, right? Hit subscribe. Go to my profile, and then watch for my new live stream, because I think you can see it when I launch it. And then you can keep following along. Also, if you're not following me on Threads, go to Threads right now. Click follow. You'll get a ton of tips on AI-driven development, because I basically do this full time, all the time. And for those who don't know me, hi, I'm Eric Elliott. I just finished a 2-year stint as an engineering manager for Adobe Firefly, which is a generative AI solution. I've been doing AI-related things since I was a teenager. Shipped my first model to production in the 1990s. I've been doing AI-driven development since 2020 with GPT-3, the very, very first version of basically before ChatGPT was a thing, the very first version that was actually able to code and actually understood the requirements and stuff like that. So I've been doing this constantly on an almost daily basis for like 5 years. And I'm writing a book on the topic called The Art of Effortless Programming, Unleashing the Power of AI-Driven Development. And yeah, follow me, get the book, and learn how to code. Learn how to code with AI. All right. We'll see you guys later.